is starting from rest, a bicyclist travels around the horizontal circular path. So maybe this is a horizontal circular path, and this is the tangent, and this is a normal. As you guys know, this is the concave side, normal somewhere here. So radius of curvature. So the radius of curvature has been given 10 meters, and the speed has a function of time. The tangential speed is defined by this expression. Agreed? So if you plug in time, maybe 1 second, 2 seconds, you can find out the speed at that instant. But do we have time given? No, they haven't given us the time to find out the picture of that location. They have given us the distance. But there is a way. If you see such a problem, you don't have time, you know the distance. So at this distance, what is the velocity? So how do you go from velocity to distance? You take the integration. So if I tell you the velocity is the time derivative of the position, and from the position you just rearrange this and take the derivative integral. So over the left hand side it says 3 meters, so 0 to 3. On the right hand side, 0 to time t. So I have made the lower limit, upper limit, I have set them up. So now we are good. Let's do the integration, your calculus skills. So 0.09 t cube over 3, agreed? 0.1 t square over 2, agreed? So the left hand side is just like a delta s, which is 3. 3 minus 0 is 3, correct? So I have done this integration. Now look, this will give us the equation for finding the time at that location. So what is the time? So if you solve for this, you can help your professor if you plug it in your computer or calculators. So if I show you the math here, it is in your calculator. You can use your calculator, but I'm using my MATLAB skills. So in MATLAB, if you want to find out the roots of the equation, you start from the largest degree. The coefficient of the largest degree is 0.03, then the second largest 0.05, third largest 0, fourth largest, which is constant. So then you write down roots. This is the function in MATLAB. So let's use this function in MATLAB. So roots point 0.03, 0.05, 0.3. Oh, negative, I forgot to put the negative sign. Thank you for helping your professor. So this is a negative sign here. So that's why I was getting some error here. So let's redo this negative sign. So I get 4.14. Don't worry about the complex numbers. Just take the real portion which has a 0, like a complex, which is the real imagine. Don't worry about. So 4. So time, either it is 0 seconds or it is equal to 4.147 seconds. So this is our time when the distance is 3 meters. Now you can take the same expression to find out the velocity. You see my point, guys? So that question was little tricky in a sense that you did not have time initially, but now you have time. Can you plug in time t equals to 4.147 into this expression to find? This is 9. Okay, this is 9. Do you get 1.96 meters per second? Now we have found the velocity. The magnitude of our velocity has been found, and now we have to find out the acceleration she has traveled. So the curve, you already know the formula for the magnitude of the acceleration is this: tangential acceleration component square, normal component square. So what is tangential acceleration from this expression? So let me grab this one and do the differentiation. So time derivative of this function, let's do. Can you guys help me? This is now time derivative, which is the acceleration tangential, 0.09 2 times t, 0.1, and at at time t equals to 4.15. Let's keep it simple, 4.15. So it is about 0.8465. You can verify at your end. Do you get the same answer? And after you do this, you can find out the normal component of this acceleration, which is equal to v square over rho. And v square, we already found the v, it is 1.96. So I'm going to write down 1.96 square. The rho, radius of curvature, has been given as 10 meters. So it is divided by 10. So do you get 0.385? And now we are able to find out the magnitude of the acceleration since we do have both components. So I'm grabbing this formula again and plugging in everything. Now you need your calculator to solve this problem. If you solve for this, you should get 0.93 meters per second square. Any question?